All right. Just get the levels there. And we're good. Hopefully, yep, mic's good. All right, welcome. Hello. Welcome to the stream. I'm Agent Ultra, where I build stuff in programming languages, such as Haskell. Why? Because people say you can't do it. That is not practical. So I like doing that sometimes for fun. And this is a stream for fun and for learning and hanging out and chatting and all that stuff. So, without further ado, I tend to build actual like stuff that I would use. Sometimes it's for learning, like just for funsies. This library I've been working on is kind of for funsies, kind of for learning, but also kind of practical as well. It's a TigerBeetle database client. TigerBeetle, if you don't know, is a financial transactions database. It's written in the programming language Zig. I don't know if that matters to you, but what's cool about it is that it's really tiny. It's designed specifically for credits and debits on accounts. So it has these kinds of concepts baked into it. They have some interesting ways of like testing things and doing distributed like consensus-ish type stuff. And like just durability type things, which I think is pretty cool. There's a lot of really neat ideas in here. I think it's a very cool project. And I'm learning more about it by implementing a client for it in Haskell. Why not, right? Good little entry point. So this project's involved like a little bit of C, a little bit of foreign function interfaces and marshalling data and things like that. And we're getting it to a point now where we have it connecting to a writing database, and we're starting to build out like more of the client level type stuff. So with that, I'm working on this little PR to kind of figure that out. And we got to figure out what to do. So, or like how to design this. One of the originally kind of started, let's get into the code. Kind of really started with this like, okay, maybe we should, I don't know, use MTL and construct a monad or monad, whatever, however you want to pronounce it, I don't know, to run our stuff in. All right, so we'll have like a TigerBeetle client monad. And this monad would have like some state in it because we need to keep track of all the requests that are made, the responses that come back to those requests, and so on. And it would have like an acceptee layer as well, so we can capture errors that happen over the state. So that made some kind of sense, I think. But maybe not so much. I don't know. One of the things I'm a little concerned with this API is forcing users of this library to pick a particular framework that they want to use for their application. So if you haven't been programming in Haskell for a while, like there's a lot of different ways you can approach the construction of a program in Haskell. And at some point in time, you have to talk to things like the disk or the network to contact other databases like this. And you do that in I/O. That's the I/O monad. It's kind of like this. It's not super magical, but it's a way of representing the outside world and things that can happen and that are not deterministic. So, I/O's always at the boundary of a program. It's where main starts, all that stuff. It also happens to be at the very bottom of almost every MTL stack. That is a monad transformer. It's kind of a slightly higher level concept than a monad. It's not too different. We build these stacks of monads. This state T is a state transformer monad. This accept T is an accept transformer monad. We're stacking them together because we're embedding the state T inside the parentheses with this accept T. And this M in the middle and the low is like our lowest level monad. And that's typically going to be I/O. Could be identity if you want to run it pure, whatever. I'm not the boss of you. but it's usually I/O. So I was thinking that maybe we should just do what we do in the raw layer here and move up some of the code, maybe break it up a little bit, but like move it up into this level here, into the client level, and do everything in I/O. I was a little worried about doing everything in I/O because I don't like programming in I/O as much as possible. But I was looking at some other libraries like PostgreSQL Simple, which is the Postgres library for Haskell, and how it handles request and response and how it provides its API. Right, and this library also runs pretty much everything in I/O. Right, with connect, creates connection, give you connection info, gives you call, you put us at a callback, it does the thing and then close the connection for you. Right, we could have a similar kind of API with client that just runs in I/O. Right, that does mean we have to make some trade-offs here, and that what we do in the raw layer already with TigerBeetle, raw client here, we have some initial kind of like sketched out code for this. That does it in I/O. Right, with client here, this version does it in I/O, which I think is probably the right way to go. We just need to update it so that it uses our new foreign pointer instead of this alloc foreign pointer. And maybe perhaps change up a little bit of the API so that you can like wrap the user's callback in this, or wrap our own callback. I don't know. We'll figure it out. But I think we should, expose this as like our main interface. And then that way, if you are using MTL in your application, when you import this library, that's fine. You know how to wrap this, right? It's just I/O, you wrap it and you put your own stuff on top of it. If you're using an effect library like Clef or Polysemi, then you know how to wrap this. It's all I/O functions. It can be all wrapped in your framework. And then I don't have to pick a framework and make you use one on your behalf, because you might not be able to integrate this library if I chose one for you, right? Because you might have already built your application in Polysemi, and there might be a way to wrap this to an MTL library to work in that, but it's not going to be the best integration, or it's not going to feel good. So I/O it is. So with that, I'm going to go up here. I'm going to get rid of basically all of this and start moving these functions from the raw layer up to here, and then breaking things up just a tiny smidge, or rejiggering them to use some of the raw layer stuff we've implemented so far. I think client ref actually is worth keeping. That wraps the raw client pointer. We can have a higher level interface. But this client state, maybe client error, not sure. We'll probably keep that, but this, we can probably go meh. And this go meh. Okay. Boom, boom, boom. I'm gonna just cut you, and let's put you here. Okay, let's get some building going. I think I got GHCID. I should probably run that. Yes. I think that would be best. Okay, cancel, sorry. No, not making, sorry, Cabal clean. GHCID, there we go. Alright, that's just gonna compile and run our program continuously and just report interesting, fun little messages to us that we like. Okay, like that. That client config isn't in scope. This needs a raw client config in order to work. Let's take a look at that. Okay. Client kind. Client timeout mid-ace. Operation timeout. Okay, cool. I don't think we're going to need client kind. I was talking with some of the TigerBeetle devs, learning about this stuff and how to implement clients. It turns out that the echo, the TB init echo call, we have this actually in the wrapped in the raw layer already. Init client echo doesn't actually connect to the TigerBeetle database. It is just for connecting to the C library, and the C library is what's going to echo what you send it. It's just to test your foreign function interface. So I don't think we need to use this at the client level. I think also I will document that here as well. Okay. So, client config now. Really just needs a timeout milliseconds. So I think we could just shaboink. Alright, we'll just make that. I want to say timeout. As an integer, some number of milliseconds. Cluster ID. What that parameter is used for. Initializing the client. Right, we have that here. Where did I put it? Was it even lower level? No. Internal? Cluster ID. So we have this one in our internal, so super, super low level. No, we have a higher level one. There, oh, there it is. Right. Okay, just a wide word 128. This is the, hey, Twitch D, or Twitch TD. Welcome to the stream. How's it going? Yes, the cluster ID is used to identify which cluster you're connecting to. So you're gonna have to know that to pass that in. So that's fine. Yeah, that makes sense. So we can probably do client milliseconds cluster ID. I think we have that. Yeah, imported there. That's good. There we go. Text. That one says its address. I think we have an address type as well. Which just wraps it. Okay, that's looking a little better as a type. So you give me the timeout milliseconds, the cluster ID, and the address. And what are we going to do with this callback? That's the next thing. So when we connect to the TigerBeetle database and we do all this stuff, we need to make a call to... Okay, well this code's only calling init and running this action. Right, because it's going to pass you the client state. And at the raw layer in the client state, you're going to get this record as your parameter and your callback. So you're actually going to get the pointer. Essentially, I think this might need to change, but this state, yeah, this is the state that you need to keep track of in order to make a, in order to like collect all the data together. So when you call with client, we're passing in an action. Maybe the action should be like one request. Right, just one. And we'll keep track of your packet, your request packet. We'll send it over to TV client. TV client will call out to your server, your TigerBeetle server, and do all of its stuff. And then it asynchronously sends us back a packet with the data that with the response. And I think we could maybe the right thing to do here is to have your like packet in your IO action here. Otherwise, yeah, we would need some way of like running. We could maybe make this something else. So design-wise, we're talking about when I call with client, I want to write something. I might want to write something like this. This is going to be just a bunch of pseudocode. Timeout milliseconds, say 3000 milliseconds. I give it a cluster ID of 123 and an address of 3000. All right, then what goes here? Right now, this would be a callback with, well, if we leave it the client state, we give it a function, and we can do more stuff here. Now, this is going to be stuff in IO, so literally anything. Which is why like people tend to reach for stuff like MTL, so you can like kind of like control what things are going to be done in here. But when you see IO, it means like, yeah, you could write stuff to disk, you could do whatever. Now, I think we agree this is going to be like kind of the way to go with this library, so that people can wrap this and provide their own framework on top of it. But what would we put in with client here? I think we also have a function in here that I would like to start getting to work is submit request. which is another I/O action. That does take a client state. Right. A TB operation, a byte string, and I/O. So I guess the idea here would be you could submit request with the client state and your other parameters. Right, whatever your TB operation is, your request data. Now this is going to return either, so you'd have to wrap this. Alright, case match on the result. We're either going to get a request error, or we get success case, a TB response. And as an IO action, we could just like show the response. Alright, we could do something like that. And then we could probably even like do another submit request. Another operation. Right. I think that's pretty reasonable. And and then we'd have to pattern match on that. So on and so forth. Show request error 2. Right, response to something like this. Now you might go, oh, this kind of sucks. I'm gonna like case match on all these results. Maybe my idea originally of using MTL isn't such a bad idea for internally here, because we could make this I can accept T M of A. Something like that. And that would basically have the effect of like instead of like binding these results and having to explicitly case match, it kind of makes the implicit thing that returning left or throwing returns the left. Otherwise, you get the result. So instead of having a case match here, submit request would just be like result 1 or response. And we could do like response 2. And then we could show response 2. All right, now we'd have to change this a little bit. Submit request would have to become, then either it would have to be an accept T of those things, but that would make the errors pure. Or, since this is all in IO, this doesn't return either. We just return the TB response, and if there was an error, we just throw it at runtime and just fail. But I don't think that's quite nice. Maybe submit request should have a request error that could be caught without having to use exceptions, like IO exceptions. So I want to get to that part because I want to start wrapping some of this stuff so that we can like create an account. And we can submit the request to create an account. So what I'm going to do for now, before I start getting a little too ahead of myself, I'm just going to try and get with client here to accept maybe some kind of callback. Maybe client state. Oh, right. Sorry. Get rid of my pseudocode. Or comment it for now. And just get it to execute and like just do something. Hopefully it'll connect. It'll... Yeah, with client should at least connect, caller action, and then disconnect. So let's try and get that to go. So in order to do that, this client pointer, we don't need alloc A to do that. We're not going to allocate it on the stack temporarily within the scope of this block. We're going to use the raw layer to get a what's called a foreign pointer to the client. That is client pointer, client finalizer, init client pointer. That's used to do it. Init client, right? Not init client echo, but init client. Right. So we either get an init error or a client pointer. Call it like that, and call it init client. It needs a cluster ID. We have one of those. It needs an address. We have one of those. It needs a completion context. I'll have to figure that one out. And a completion callback. Okay. So get rid of the allocating client pointer. We'll de-indent all this stuff. Okay. The next thing the code wants to do is initialize a client state. Okay. This is where we initialize the completion callback. Okay, so that's going to take the client state. We have a bit of a dependency here. And that the init client needs some things that the client state needs and the callback state needs. The callback needs client state. In order to get a client state, well, we need a client pointer. And in order to get a client pointer, well, we need a callback. And so we have this loop. I think, what do we need the client state for? It does quite a bit. Like, for example, with submit request. What do? We want to atomically read the T-bar in the state. See if it's shut down during request. Okay. And then take that result. If there's an error, raise it. Otherwise, packet pointers. something like this. We poke the context pointer to a packet. Okay, interesting. Create a TV packet. Poke the packet pointer. Okay, let me submit it. Okay, use the client pointer to make this FFI call. Okay, so maybe what we need to do is break this up a little bit. Okay, well, let's address initializing the callback, completion callback first. Let's look at that one. That comes from all the way down the FFI layer. FFI. Client probably. Yeah, exactly. So this is just creating a function call, a function pointer, or a function of this shape in Haskell. In order to make a callback, you need the completion context. You need a pointer to a packet. A word 64. This might be documented in the C library. Pointer to word 8. I think that's probably the, I want to say the cluster ID. Word 32, and it's an IO action. So we don't need the pointer to the client. Don't need that foreign pointer. We don't need anything else from the client state. Much from the client state. Maybe this TV completion context thing. But otherwise, nothing else. Okay, so we should be able to figure out what set of completion callback needs from the client state, and then maybe separate that out. We do pick up, we get the packet pointer context, timestamp, result pointer, result when. Oh, this is the callback. Yeah, okay, to state. What do we use from the state? Active requests. Active requests. Free requests. That's it. Okay, so it's setting the completion callback up here. We're only using this CS active requests map and the free requests TQ. And that's it. Right, which makes sense. We're not making any calls to the libtb client C library here. We're just getting, this is the result we're getting back from that library. So the packet pointer is a pointer to the response packet here that we've received asynchronously. So this code is just like writing that to this variable in this requests map. So this client state could be used in our situation here, in our like test code, right? Where you submit this request. They'll get submitted in sequence, but they come back asynchronously. And so if we hold on to the client state out here, I guess the way we're supposed to read that those responses back out is to pull out our client state. Int map to request context. A context for single request. Okay, so we have the context ID and the result. A TM bar, which will be in either TB response or request error. Okay. All right, and that's included in int map. Okay, so I guess we'll need an interface for that. Because I don't think the people using this library to write clients are going to know to look at request 1, request 2, request 3 necessarily, right? Right, like when I make a connection to Postgres, for example, and submit a query, even if it could be async, the results, but the results come back at some point, right? And if it's async, I might give it a callback. It'll get called with the results of my query when it's done, so on and so forth. So I'm wondering if this is going to have to change at some point. The client state is going to have to be internal to with client, and the callback really should be results. Or no, it can't be results, can it? Because we're going to be submitting the request here. I don't know. Or this would be like results. Something like that, maybe. Okay. So, completion call. Let's split up client state to separate out the client pointer. I think we could just remove that. And the other ones, I think, are going to be fine to keep, except the timeout millis here is going to be timeout. Okay, go to raw. Go to client state. Get rid of the pointer here. All this really cares about mostly is this stuff. Okay, deinitializing the client. Yes, you do care about it there. And finalize client. We can return that functionality to you by giving you the client pointer directly. Yeah, that doesn't work. You have to do with foreign pointer, client pointer, client. And 285. Okay, submit status. So this is in submit request probably. Yep. Okay, so we can return this functionality to you like we did before with the other function. By pulling that out to a parameter. And then we can just call it here. But we're going to have to unwrap the foreign pointer again, so we're going to go to that. We're going to do this. With foreign pointer. Pointer. Raw client. Cool. Right, we don't have DB in its status and scope here. That comes from FFI, I think. Yeah, which we don't really want to be importing at this level. But I'm gonna do it now, for now, just to make it compile. And then we'll fix it up later. Yeah. And then we can do all there and FFI dot. There we go. Okay, I am. Int map. I should probably get the type as well. There we go. Need byte string. Text encoding. And then over here, yeah, we got rid of this. So the init function is just going to be FFI TD client init. Echoes just for testing. FFI stuff. Doesn't actually connect to the database. Doesn't do anything in that regard. So I can get rid of that. And since we're just changing the name, we don't really need the let binding there. Okay. Let's see, this error here is 52. Right. Okay. So now that that's separated out, completion contact can make with client state. Now the client state doesn't need the client pointer. We need the completion context, something like that, but we need the function pointer for the callback. So now we can move the callback. We can move the client creation down here. And this will be callback here. All right, and then client state. New tvar IO is not a scope. Yeah, that comes from current, all this stuff. This might be overkill. And then init client, also qualified by raw. Cool. Now we just need a completion context in order to initialize this client. So what's TV completion context? I gotta remind myself what that is. Let's look at the library. Okay, so it's an unsigned int pointer. And it looks like it's given as the first argument to the callback, the completion callback. Okay, we have this function TB client completion context. Retrieve the callback context initially passed to TB client init or TB client init echo. Return value is TB client okay on success, TB client invalid. If the client handle was not initialized or has already been closed. Okay, so this is a handle to identify a client. Okay, where the data, who's originating the data, and who's to send it back to. Okay, so TB client submits a packet with its operation data and data size field set. Once completed, completion callback will be invoked with completion context and the given packet on the TB client thread, separate from the caller's thread, because it's run as a foreign library, I guess. Return value, TB client okay on success, or TB client invalid if the client handle was not initialized. Or is it being closed? Okay, so I guess internally the library is like running each of these on separate threads or potentially in an event loop of some kind. And since it gets the response asynchronously, it's like putting those back to the caller thread. Okay. Okay, register. Oh, that's interesting. I think that's pretty new. Register log callback. Okay, cool. Okay, so I think for that hole, that means we can put something there for now. Okay, and right. So this init status stuff isn't necessary at this point. I don't think that is either. Just this finally block, I think, is all we need now at this point. What was I missing on that? I see. Yeah. We can get rid of that. Oh, sorry. It's probably more like... Yeah, we do get an error here. Okay. So we match on that, and it results of... Okay, and then if we have right, we have the client pointer. An error maybe, and... Well, I'll finalize client on that. Okay. Okay. Yeah. So it wants a natural number there, not necessarily an int. And we could do that. Not that way though. It wants... Yeah. It wants the GHC num natural, interestingly enough. This cap, often used for type level things. Let's look at the client state. Natural, yeah. Where do you get natural from? You actually import it as GHC.natural. Okay. Not a huge fan of that, but that's okay. We can do similar things. Just change the type alias and add the import here. Okay, and run a client state to IO. Okay, missing an argument there. Probably the pointer, yeah. Okay, so to get that to go, we just need with foreign pointer on client. Or the better approach might actually be to use the foreign pointer library to do this instead of finally. But now we have that. Oh no, it actually wants the client pointer itself. Okay, that's fine. Sorry, my bad. Doot. And yeah, so we don't want FFI, we want raw client init error. Okay, and then oh, I accidentally M. Okay, it should be an A. Yes, we got rid of that. Got rid of that. And then a bunch of other things in other modules, which is why I like running GHCID, because like it really, even though like I can get my type checker to run within my Emacs buffer here and like show me all the type errors within my buffer, GHCID also kind of gives you a bit of a global view, even though it doesn't directly integrate, which I kind of like less, but maybe I think there might be a way to do it, to integrate it more directly with your editor so you can kind of jump to these errors. That would be super sweet. There are packages to do this that I haven't been using a whole lot of my side projects, but I use them at work. It's called GHCI Watch. It has some Emacs integration. It's a little bit better. I should probably give it a go. Alright, so it runs a GHCI for you. It does a bunch of smart directory watching. And stuff. It's pretty cool. That'll be for another time. Okay, let's go fix up count. So in this module, this is like where I was thinking we would like wrap the individual like different operation kind of interface type API stuff. So eventually I want to get this create accounts action to work. But we don't have client anymore. We just have IO. And submit account and stuff like that. Let's see what we got so far, code-wise. Right, with client. Okay, so it looks like we got basically got with client to compile. Moving it up from the raw layer into our higher level interface here, and just getting it to work with some of the other stuff with foreign pointers and so forth. So let's stage that. We'll create a little work in progress committee commit for that. And then we'll try and get the create account stuff in the account module to also work. Applied, the project will move RADA with client. Replace client. Places database. Beetle. Replace high level with client. With the raw with client implementation. Substituting client initialization client. There we go. Well, it's probably good enough for now. All right, so now we don't have client M. These are all going to be in IO now. We could make it a little bit more general with mode.iom. Now, because it's not FFI client okay, there's a problem. How do we want to surface problems? I'm going to err on the side of caution and suggest maybe we return to either here. Client error or unit. So then we replace throw error with pure left. Client error, I think. And then we have oh, right. Otherwise, pure unit. Right, unit. Right, no, well, let's just change this. I'll make a client error like that. Okay, we all compile, we're back to green, that's good. Probably doesn't work yet, so let's just make it a work in progress commit. Okay, now yes. Okay, so we could actually maybe implement create accounts. This could work. And that would tie together with client. So my example would be like response. Create accounts. All right, and what does it take? So like a list of create account things. You want an account ID and an account ledger. Let's just say this. Right. And it runs in or out, returns either client error or whatever. And so then we should be able to display that. I think that would work. Get that. Okay. Oh, no, we need something from there. Okay, this. You and you, maybe? I know. Yeah, okay. Now you're good. So we should be able to write a little testy test to be able to create an account now, I think. Well, no. We gotta create accounts to work. Right now, it will lift.io this undefined thing and not do the right thing. So this code has to now call the submit request stuff. Let's call submit request. It's going to need the client pointer, the client state, DB operation, a byte string, and such. Okay. I think there's going to be a refactoring in our future once this is all done, but so far, yes. I think we can replace that undefined with that. More like raw to submit request. Alright, it needs the client pointer, the client state, TB operation, byte string. Okay. Okay. Doing a fair bit of work there. We're doing alright for time. Okay. With packet pointers. I'm not as super sure about that. I think we're going to take a step back on this. Stage that. Let's rebase that from here, squash those in, reword that one. For providing library primitives, IO, so that the user can pick any framework and wrap it any framework they need. Okay, that's cool and good. All right, now, creating accounts. Ooh, pardon me, it's getting the end of the stream, isn't it? All right, chatty chat. Getting to the end of the stream, we're getting there, we're making progress. What did I want to do? I wanted to just test with client actually connects to a database and like, we don't have to put anything in there. It just does nothing but connects and then disconnects. And then supposedly in the future we'll add a proper thing for it to do. Okay, what's the best way to do this? We have this application binary. We could probably mess around with this. Try it out here. I think we need to set up integration tests at some point. So we're going to import database TigerBeetle client. Hopefully, actually, I think we re-export everything we need from there. Let me get my test code, or my pseudo code. I'll actually use that. So instead of that, we're going to go... here, we'll just do call.pure. Or... build. Ugh, ugh. Gotta fix those. Okay. Oh, yeah. Language overloaded strings. Handy dandy. Oh no. What's going on here? Hey, Twitch TD, thanks a lot. You have a good time too? Happy hacking out there. Okay, we're getting link errors. Oh, I'm probably not in the Nix environment. Am I? Oh, wow. Okay, that's not unexpected. Okay, interesting. I thought we were pretty much over this. What's happening here? Because we've been able to get the linking to work within the REPL when we've been testing stuff here, but building this executable, are we not, maybe we're not defining the wall file properly when building the executable? TigerBeetle HS. It's TM, but we also need to depend on the library itself, libtb client. That might be it. Cool. Library path. Dynamic library path. Extra libdrs. Yeah, okay. Extra libraries. libtb client. Now, hopefully the linker can find those paths in the Nix environment. Without us having to do library. Okay, missing or bad C library libtb client. Okay, so yeah, I guess not. I don't want to have to specify the path because that comes from Nix. That's a Nix generated path, and I don't know what it's going to be in this Cabal file. Did I maybe just name it wrong? Maybe I don't need the lib prefix. Progress, linking, okay, cool. Alright, that's better. Alright, so let's get the TigerBeetle database running. TB, I think we've got a database already there, so let's just go TB run. And then we will tail F the logs. Okay, and then we will run this executable, and I think what will happen is that we should, or at least we should see in the logs the connection and then the disconnection when we run our executable, and it does basically nothing. Vol run TigerBeetle HS. Okay, it's kind of just hanging out. What's going on? Are you doing anything? Oh, maybe it wouldn't do anything. But I'm also not seeing our connection. That's our program. With client is going to make our completion callback, get our init result. This is what I expect us to get to, so that we get the connection string at least. Now, running our action, and then finalizing the client. Action doesn't do anything, so that should just return unit and just do nothing. Yeah, I don't know where it would be. What would be hanging on? This is a TigerBeetle, I mean, a Cabal hang or something. Time to do a little debugging, old school. And pop one here. Client start. We'll go with client state is. Show the client state. Client, we need callback. With client init results is show init result. Not there. Not there. No, show up a client state, that's okay. Made state. Okay, so we potentially do get the connection. Okay, that's all good. So it's something interaction. Here. I'm just gonna put Sterling hello world. Okay. It's calling our action. What is it waiting for? Is it finalized client? Maybe that's causing the problem here. Could be. So we do atomically two transactions. So I love the STM library, by the way. I think it's the greatest thing since sliced bread in Haskell land. And it is one of the one really strong reason for choosing Haskell is its concurrency story and the libraries around it. It makes writing concurrent code pretty awesome. So every time we see one of these atomically things, this is a transaction in memory. So finalizing clients, trying to write to this tvar value in the state as Boolean value. Well, there's this discussion here, this little comment here, we should probably read that. Race condition, once we release from this transaction, completion callbacks may fire and overwrite our shutdown error in the request result var. Conceivably, this is fine. The below block just ensures that all submit request invocations that are blocked on the request context result var are allowed to proceed. This should effectively flush all active requests, since is shutdown flag should prevent new requests from coming in. Process interleaving shouldn't cause any active request entries after this block due to using a stale is shutdown value because the flag is read in the same atomically block as active requests are written to in submit request function. Okay, maybe, but is the race condition not a problem? If there is a race condition here, I don't know. So the second transaction we have atomically, we read the active requests, and then we put some stuff in the result bar. We iterate over the active requests. And then once that is done, we call with foreign pointer and deinitialize the end of the client. Maybe it is getting stuck in here. Don't imagine it would be getting stuck in there. Okay, so let's clean up all of those. Get a little committee commit for that. State /main. Add a simple test program. Alrighty, ready. So let's debug in here. Oh, we do post qualified here, don't we? Okay, so let's drop one in here. And then here, yeah, we're atomically doing that. And we drop one here. Shut down requests. And then we should deinitialize the client. Okay. Shut down requests. Is it hanging on the dinit? Okay. Do. Okay, it is the library. We get to about dinit, and then we've got nothing. Okay. Interesting. Yeah, that might be it. That would be problematic. Okay, cool. Didn't need to use with foreign pointer, give the raw pointer. Or FFI, no, sorry, this is calling FFI dinit. We only need call dinit client here. I mean, this code technically isn't wrong, but let's just clean that up. dinit status raw dinit client. Client pointer, client PTR. There. let's just show the DNet status there. Oh, I don't know. Okay, we get the hello world, we get to finalize client start, we get to shut down requests. Okay. So now we are in here. We are calling the FFI TV client DNet. So it is definitely something to do with the DNet call. I wonder what's going on there. Let's dig in. It takes the pointer to TB client, the foreign, well, the raw unwrapped from the foreign pointer. Calls RC TB client DNet. Gets the result back, fmaps over that to get the integral and converts it to an enum. Okay. Closes the client, causing previous submitted packets to be completed with TB client packet client shutdown, or freeing any allocated client resources from init. On success, client valid if the client handle was not initialized or has already been closed. But we're calling C underscore TB underscore client. Init, what is that from? Okay, that's just the raw foreign C call. I guess like the C is underscore is the convention. It's hanging for some reason. I don't think we have time to dig into the source code for the client library on this. Why would it hang though? Well, we don't have a ton of time, but let's go take a quick little peek. Go to clients. See TV client. It's actually written in Zig. That's not it. Is all this? Signal fuzz packet. Struct. Nope. Nope. Ah, here we go. DNet. It doesn't look like he's doing a whole lot, right? Like... So, I guess it's like, how does FFI here to refer to a point, dereferencing a client interface pointer? Or, call client.dinit. Switch on the error result. Return either .invalid or .ok. Client interface. Search client interface. Context, okay. Okay, VTO, oh, good times. Object, is this object-oriented programming? I know what vtables are. Submit function, completion context function, dinit function. Okay, so if client.magic number, return error right away. Return 0. Create a context. Lock. Unlock. We defer the unlock. If the pointer is null, we return invalid client. Otherwise, we defer this assignment to it. Not sure what this means. And then we call this dinit function context, whatever the heck that is. Maybe it's locking in there for some reason, not getting to the unlock. But I'm guessing it's somewhere in the library. However, we'll have to debug this another time. For now, let us review what we've done tonight, create a commit, push all those things up, and we'll figure it out another time. Okay, that's just debug stuff, so I'm going to get rid of that. Rebase that. I'll just reword this. Those are good. Let's push them up. Oh, I have some updates I didn't pull down. Hopefully no conflicts. Oh, we're good. And there we go. Okay, so a little bit of prog. Not too bad. But we'll have to find out what's happening with the locking there. Why is it not deinitting properly? However, all the code you've seen tonight for this project is available on GitHub. I'm your wonderful host, Agent Ultra. I just closed it, didn't I? I did. Here on GitHub at agentultra/TigerBeetle-HS. So if you want to come check that out, give it a star, follow along, that would be great. Paste in the chat there for you. And you can follow my work and what I do in my posts, both sometimes hopefully funny, sometimes not, I don't know. But programming stuff mostly. Try to content warn, when I'm talking about other things. But mostly programming. You can find links to all my stuff like my website, agentultra.com, my Twitch stream, which is here that you're watching, hopefully, or if you're watching on YouTube, there's my link to my YouTube where I back up all my VODs for all these streams, and you can check that out there. So it's been a slice. Thanks for following on and watching. Give me a follow on the Fediverse if you want. I'm on types.pl/agentultra, on the types.pl server there. And you can also check out the link above my head. That's declarative.tv. They've got listings of a bunch of other streamers who are doing cool stuff in different programming languages. Some of them are also doing stuff in Haskell as well. And there's a link to a Discord server. So if you can't chat here because you're watching on my VODs and backups, or you think of the question that you wanted to ask on the stream later, there's a channel there on the Discord server for this stream where you can ask those things. And just hang out. So thanks again for watching. May all your monads be free and your types always check. I do these streams once a week on Wednesdays now at 10 after 8 in the Eastern time zone. So like, subscribe, give us a follow here on Twitch, set your notifications, get prepared, be ready, do what you need to do, and we'll see you next week. Happy hacking out there. Take care.